So again, what we want to do is we want to establish the boundary between where things are positive and negative. Okay, where the inside is equal to 0. The 0 represents the boundary between positive and negative, because when it's positive, the inside is positive, the absolute value doesn't do anything, it doesn't change anything. Where the inside is negative, the absolute value will change it to its opposite. Okay, so we need to establish the inside being positive. That's going to be one piece, and this is our piecewise function. And when the inside is negative, and to do that, we establish our boundary of 0. Boundary here is going to be when x equals positive 3 over 2, okay, or 1.5. So where is it going to be positive? Well, if this is bigger, x is bigger than 1.5, then we know that it's going to give us a positive value. Okay, the inside will be positive. So we're going to say when x is greater than or equal to 3 over 2. And when that's the case, we end up with the expression is equivalent to 2x minus 3. So nothing changes. Okay, so absolute value of any number is bigger than 1.5. So for example, x is 2. 2 times 2 equals 4. Minus 3 is 1. Absolute value of 1 is 1. It doesn't change. This will give us the same value if we calculate it in here. The other piece then would be the other part when x is less than 3 over 2. If x is less than 3 over 2, we're going to end up with a negative. Well, what would the absolute value do? Well, it's for those values, it needs to do the opposite. Okay, so we're going to take the negative 2x minus 3 and make it into its opposite. And that will give us a positive value. Okay, so I'll give an example here. When x is 1, it's less than 1.5. So in this case here, let's plug into here first. 2 times 1 minus 3 is negative 1. The absolute value of negative 1 equals positive 1. So we need to get the same calculation here when x is 1. So 3 minus 2 times 1 gives us positive 1. So this is going to give us the exact same calculation as this when the numbers are less than 1.5. So there it is. We've now written this as a piecewise function. So again, the key, I'm going to highlight this. This is our key, our boundary. Okay? The boundary is our key. When inside equals 0, this is a key. Okay, so this is a key idea. So then when I have a quadratic on the inside, we have to kind of think, well, when is the inside equals 0? Because that will at least give us our boundaries. Now, it's a little bit more complicated than that because we need to know when that inside is going to be positive and when inside is going to be negative. But at least if I factor and find the zeros, okay, I will at least have a starting place for this. So I'm going to factor this into x minus 3, x plus 3, and at least I can establish my boundary. Boundary is going to be when x equals 3 and x equals negative 3. Okay, so my domain is going to have 3 parts. I have boundaries represent the word divides things up, and I'm just going to draw a number line down here. Okay, so this is my domain number line. I know what negative 3 and positive 3 represent boundaries. So I have a region here where it's going to be either positive or negative. I got another region in here on the other side of the boundary. It's going to give us positive or negative. And I got another region over here on the other side of the boundary, which is going to give us negative or positive. So we have 3 different parts that we have to deal with. Okay. Now the only options really are positive and negative. So we're going to have our 2 parts for our domain restriction. Okay, so we're still only going to work with inside being positive and inside being negative. Okay, so we can do a check here. So when is this inside going to be negative? Is it going to be negative when x is out here, in here, or out here? Well, if x is small, in between here and here, okay, we should get negative. Okay, because we're going to have a small number, minus 9. If we have large values of negative and square it, we're going to get large positive, which is going to give us positive. Here, same thing. So our negative values are going to happen in here, and our positive values are going to happen out here. Okay, so our inside being positive domain is going to be when x is less than or equal to negative 3, or when x is greater than or equal to positive 3. And then our inside being negative domain is going to be between negative 3, and positive 3. And it's going to behave differently depending on that. So if it's positive, nothing changes. Okay, we just keep the inside the same. If the inside is negative, we need to do the opposite. We need to take that negative x squared minus 9 and make it into a positive by making it putting a negative on it. So these are our two parts of our piecewise function, this piece and this piece. Now there's one other way we can kind of help visualize whether the inside is positive, the quadratic is positive or negative. We can actually visualize what this quadratic looks like. This is a parabola that's opening up, and it looks like that. And the inside is positive where it's above the x-axis, here and here, and the inside is negative where it's below the x-axis between negative 3 and 3. So that's another way we can think of it. If we want to be able to see math, we want to see what the graph, understand what the graphs are doing. And the graph does help us establish where that x squared minus 9 is positive above or negative below.